Let's do the connections to make the capacitor charge next. But there's more to the connections than just charging the capacitor. Let's find out what it is. So here's the logic. When the output of the 𝗙𝗴𝗲 timer becomes high, the capacitor charges. For that, we will connect the out pin to the capacitor as the positive connection. Once the output of the 𝗙𝗴𝗲 timer becomes low, the capacitor discharges as it is connected to the negative rail of the breadboard. Now, let's move on to the connections. But we shouldn't directly provide the output to the capacitor. As the current is high, it might damage the capacitor. Well, we have a trick to control the current to the capacitor. How, you ask? Using a resistor, of course. Just like how speed breakers help slow down vehicles, the resistor will limit the current flow to the capacitor. This in turn will control the charging and discharging of the capacitor. So let's bring in the resistor from the components library and place it on the breadboard. Alright, now let's provide the output to the capacitor. So we have to get our wires and start the connections. Take a green wire and connect the out pin to one of the terminals of the resistor. Now change the wire color to red. Oh, don't get confused. It's simply to typify that we are providing a positive connection to the capacitor. So, connect the other terminal of the resistor to the threshold pin. See what we did here? We provided a positive connection to the capacitor, and along with that, we provided the high-low output of the 𝗙𝗴𝗲 timer continuously to the capacitor. This is called feedback. We have completed the connections. Are we clear on how things work? Well, when the output of the 𝗙𝗴𝗲 timer IC becomes high, the capacitor charges. And when the output of the 𝗙𝗴𝗲 timer IC becomes low, the capacitor discharges. And as it is connected to the threshold pin, the input repeats continuously. I am super excited to see the results. Are you? Come, let's click on Start Simulation. Oh, the LEDs are glowing alright, but they are both glowing at the same time. That's not what we needed. We wanted them to blink alternately. So, let's stop the simulation. Did you know when the term fairy lights were first used? It was first heard in Savoy Theatre 135 years ago. It was the first building in the world to be lit entirely by electricity. I am not going to give up, and I know you will not too. Alright, let's see what we can do. Oh, I know. Click on the capacitor. And yes, see the capacitance value of the capacitor is 100 nanofarad. That's too low. Let's change it to say 10 microfarad. Good. Also, click on the resistor and you can see its value as 1 kilo ohm. You know, dear, if we reduce the current to the capacitor, we can actually produce a time delay. To reduce the current, we have to increase the resistance. So let's change the resistance to 100 kilo ohm. Finally, it's the moment we have been waiting for. Let's click on Start Simulation. And hooray! There's our fairy lights. The green and yellow LEDs are toggling between each other. It looks so shimmery and beautiful, doesn't it? Since we got what we wanted, let's stop the simulation. We did a lot, right? We learnt about 𝗙𝗴𝗲 timer IC, added LEDs, capacitors and resistors, and finally made the fairy lights. Hey my friend, these are the fairy lights that I made with your help. Look how beautiful they are. Thanks to your help, they work like a charm. Do experiment with all the things that we learned today. I will meet you with another interesting project. Until then, bye.